Think about the internet. We treat it like an invisible cloud, but it has a very physical address. Right now, that address is a series of massive windowless server farms, owned and tightly controlled by a handful of tech giants. This data visualization shows the immense physical toll those facilities take. In 2024 alone, U.S. data centers consumed a staggering 183 terawatt-hours of electricity. That is an enormous, concentrated drain on our power grids, driven largely by the heavy computing demands of artificial intelligence. And when you concentrate that much power and data into a few massive hubs, you create a fragile system. If a storm, a power surge, or a software error hits one of these facilities, it becomes a single point of failure. Entire regions lose access to critical digital services in an instant. We have built our modern digital lives on a brittle foundation. These centralized fortresses demand immense resources from our local communities, while keeping the profits and control locked tightly behind their own doors. But there is a different way to build this infrastructure. All around us, millions of idle desktop computers, home routers, and vehicle dashcams are starting to wake up and connect to each other. This is happening through a technology called DePIN, which stands for Decentralized Physical Infrastructure Networks. Instead of relying on one massive corporation to build a data center or a cell tower, DePIN pieces together the spare capacity of everyday devices. It takes the heavy responsibility of storing data, routing internet traffic, and processing complex computations, and distributes it across a global community. Control shifts away from a corporate boardroom directly into the hands of the people providing the hardware. Plugging a device into one of these networks connects it to a community-owned grid. Every byte of data processed or stored through that connection generates direct compensation for the hardware owner. Think of it like the sharing economy model used by companies like Airbnb or Uber. Those platforms connect people who need a ride or a room with people who have an empty car seat or a spare bedroom. This diagram illustrates how that exact same logic applies to digital infrastructure. Instead of a telecom company spending billions of dollars to build a massive new cell tower, they replace that heavy corporate spending with a grassroots approach. Small, interconnected nodes light up inside individual homes and vehicles to provide that exact same coverage. The glue holding this together is an automated incentive system. When your router provides wireless coverage, or your hard drive stores encrypted files, the network's protocol tracks your contribution and automatically pays you in cryptocurrency. This creates a self-sustaining cycle known as the flywheel effect. The financial rewards attract early users to set up hardware. That hardware creates a reliable network, which attracts paying customers. The revenue from those customers increases the overall value of the network, which then attracts even more people to plug in their devices. By crowdsourcing the equipment, these networks bypass the billions of dollars in upfront costs that traditional tech giants face. They deploy hardware across the globe faster, cheaper, and far more efficiently. Projects like Helium are already proving this works at scale. It bypasses traditional telecom monopolies by letting individuals set up small internet hotspots in their windows. Together, those users have built a global wireless network, providing 5G and connectivity for smart devices, earning tokens for every byte of data they move. Then there is Hivemapper, which takes on the massive task of mapping the world. Instead of deploying fleets of expensive corporate vehicles, it pays everyday commuters to mount a specialized dashcam in their cars. As they drive their normal routes, they map the roads and earn digital rewards. And for high-powered computing, networks like Render allow people with high-end computers to rent out their idle GPUs. A GPU is a graphics processing unit, the specialized chip inside your computer that handles complex visual math. Render pools these chips together to process intense 3D animations and train artificial intelligence, paying the hardware owners for their processing power. These are active, multi-billion-dollar ecosystems processing millions of real-world tasks every single day. Because these networks are built from thousands of individual, independent pieces, they behave differently from traditional tech infrastructure. A centralized data center is static and rigid. A decentralized network acts more like a living, breathing organism. If an outage knocks machines offline, the mesh network instantly reroutes data through active nodes, healing itself to prevent regional blackouts. As demand surges for live AI inference, the network scales immediately by incentivizing more users to plug in, avoiding years of mega facility construction. By distributing the workload across a vast, decentralized web, we get an infrastructure that is naturally resilient, deeply adaptable, and uniquely equipped to survive the heavy demands of our modern technological era. The era of corporate-owned, monopolized infrastructure is ending. Control is migrating away from the center and out to the edges of the network. This shift creates a massive opportunity to monetize the hardware you already use. Simple devices in your living room or car can generate a passive income stream by providing the storage and connectivity the digital world requires. Contributing to these networks puts physical hardware back under your own control. Every participant helps build and maintain the digital foundations they use every day. We are building the next generation of digital systems out of devices in our homes, in our cars, and in our pockets. It is a massive, collective infrastructure designed to pay us for every connection we provide.